Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to another episode of the ARC Advisory Group Smart Cities podcast. I'm Eddie Fidler. I'm a transport analyst at ARC. And I'm happy to be joined today by Joffrey Wilson, Strategy and Market Development Director at Mortenson. Hey, Joffrey.
Good morning. How are you?
I'm well. How are you?
Very well, thank you.
Great. So maybe just to start, Joffrey, you could introduce yourself and Mortenson to our listeners.
Sure. I'll start with Mortenson. Our firm is based in Minneapolis, Minnesota, with a presence throughout the U.S., and the company's businesses are real estate development, commercial construction, and energy and infrastructure. With respect to energy and infrastructure, the businesses are renewables, so solar and wind farms, power delivery, which is transmission lines and substations. And then we also focus on distributed energy solutions, including battery storage, electric vehicle charging, and microgrids. In terms of myself, I work as the Strategy and Market Development Director for our Energy Solutions business. So we focus on engineering, procurement, and construction services for EV charging infrastructure and microgrids. I've been with Mortenson for 4 years. Prior to working at Mortenson, I worked for a couple different firms, Ford Motor Company and General Mills, in marketing and corporate strategy roles.
So could you tell us a little bit about how Mortenson got into the EV infrastructure business? Describe the opportunity that you guys saw in that space.
So Mortenson started in commercial construction in 1954. The company has a history of trying to get into new industries and to be innovative over the years. So we entered the hydroelectric space in 1976. We then moved into renewables, first with wind power in 1995. And then solar in 2009. Over the years since then, we've launched new businesses, including power delivery, energy storage, EV charging, and microgrids. With respect to EV charging infrastructure, it's really tied to watching the trends in the industry. We tend to subscribe to different organizations, attend conferences, and we have team members that focus on what are the trends that are coming. And watching the trend that more electric vehicles were expected, and significant infrastructure was going to be needed in order to support those vehicles, we decided to move into that business. On our commercial construction projects, there are often electric vehicle charging scopes. So think of the 5 or 10 chargers in front of a building. But beyond that, there's bigger infrastructure needed when you talk about larger vehicles with bigger batteries or fleets where you have more vehicles charging at one time. So the complexity associated with EV charging infrastructure is exciting to Mortenson, and one of the reasons we decided to invest in the business.
Okay, so as we get into the infrastructure part of EVs, that's sort of an area that people don't really pay as much attention to as we probably should. So maybe you could just walk us through what goes into EV charging infrastructure. What are the components and parts of that to get the power from the utility to the vehicle?
There are 4 different types of electric vehicle charging infrastructure. There is EVSE, and that is electric vehicle supply equipment. That is largely the chargers that I'm referring to there. So when people ask about electric vehicle charging infrastructure, it's chargers that are usually top of mind. The other types of infrastructure include facility infrastructure. So we think about panels and meters and feeders, medium voltage. There's then electric service infrastructure. So transformers, substations, this is largely larger upgrades utility-wise. And then the last type of infrastructure is distributed energy resources. So battery storage, which can play a role in EV charging infrastructure, perhaps helping to reduce peak demand charges or provide resiliency, or renewables. On-site generation like solar can help with large-scale projects as well. So those are the four types of infrastructure. Not all four are going to be relevant for every project, but it's important to understand that each project, depending on what power is available on site and how much charging is going to take place and what upgrades are needed, any one of those four may be required.
Okay, got it. So a lot goes into it. Could you talk about the process for actually establishing and preparing and building out that infrastructure?
Yes. So I would say that when fleets are thinking about electrifying their vehicles, they tend to think about a comparison of vehicles. They don't tend to think about infrastructure soon enough sometimes. Infrastructure has been found to be the number one barrier to electrification based upon some studies that we've done and work that we've seen. In terms of the steps required in order to establish infrastructure, it really starts with a site assessment, determining what's going to be needed at the site, where charging is going to occur, and what's currently in place. Beyond a site assessment, we determine what capacity is available power-wise and start to think about what infrastructure is going to be needed on the facility, what infrastructure beyond the facility in terms of electrical upgrades may be needed. After that process, a design takes place. So there's some engineering which can include physical, electrical, or it can include civil engineering as well. After design is in place, the construction process begins. So in terms of construction, the scope of a project is going to range from perhaps less complex if it's only EVSE, and it can be more complex if it includes things like storage or renewables. After the process of construction is complete, there is a commissioning process that takes place and training. So that's a high-level description of what it takes to establish infrastructure. I would note that one of the key components of establishing infrastructure is working with the utility. Utilities are responsible for delivering power. There is an interconnection process that can be required to establish any electric infrastructure. So the utility is one of the key stakeholders to engage early in the process.
And so tell me more about what that looks like, especially on that sort of back end, softer side, working with the utilities, as well as governments. I'm sure there's regulatory and issues like that come into play here as well. Zoning.
Yeah, there are a lot of different stakeholders that may be involved in the process. I think one of the benefits of electric vehicles is that it's a win for many of the different stakeholders. When I think about utilities, one of the benefits of electric vehicles is it's more load, so more demand on utility services. When I think about municipalities, there is the potential to reduce carbon emissions in part through electric vehicles. For vehicle drivers, the performance of these vehicles is fantastic, and in cases, there's opportunity to reduce total cost of ownership. So there are a lot of different stakeholders that may be involved in the process. That is one of the complexities that comes into play as it pertains to establish EV charging infrastructure. It is new. These technologies haven't been in the market for a long period of time. So there's a lot of stakeholder engagement and management required in order to establish infrastructure.
But as you alluded to, that's partially what's driving the whole industry as well, because it is such a win-win-win all around.
Absolutely. And I think the story is going to continue to get better. Today, I mentioned that one of the barriers is infrastructure. As we get more infrastructure in place, I think we'll see more vehicles electrifying. The other opportunity area, though, is vehicle availability. There are not enough electric vehicles available today. There aren't models available in cases that some customers may be interested in. So there is going to be more opportunity moving forward as we establish more infrastructure. and as more electric vehicles become available.
Right. That's been a serious barrier for a while, though it is heartening to see, especially more recently, that's really been changing. Both in light duty, private vehicles, and commercial as well. But God, until 2020, 2019, that was one of the biggest headwinds, especially for medium duty, delivery vans, commercial applications like that. There was just kind of a desert of models.
Yeah, as we watch vehicle availability, 2021 is actually a key year. There are some manufacturers that are going to have delivery vans available in electric forms. Examples are Rivian and Arrival that are slated to have vehicles coming pretty soon. The Ford Transit as well is something that we're waiting to see. Then also in the US, a lot of our vehicles are SUVs and pickup trucks. Ford, for example, is going to have an electric F-150 coming out here next year, I believe. There SUVs that are going to be available as well. Rivian, I know, is starting to develop and hopefully will have available an electric SUV soon. Those are a few of many examples that'll be in the marketplace in the near future.
Yeah, and that's what makes it such an exciting time to be in this industry. We're really watching it bloom this year and next year and early in this decade. So that's a lot of fun.
Absolutely.
So getting back to infrastructure for a moment here, can you talk about some of the misconceptions about EV charging infrastructure, apart from the fact that you don't need to think about it until you're installing?
Well, one of the biggest misconceptions for many is that the infrastructure goes beyond the charging units themselves, the EVSE. I don't think a lot of fleet owners that are thinking about electrification have thought about what infrastructure is going to be needed. We covered that a little bit previously in this discussion. But one of the other misnomers is the fact that infrastructure can be pretty complex to actually implement. The timelines vary widely. There are projects that are completed in terms of establishing infrastructure in 6 to 9 months. There are also projects that can be 2 years and beyond. It really depends on what power is going to be needed, what capacity is already available. Every site is going to be very different. But if you talk about major electrical upgrades that can be needed, the timelines vary widely. The other misconception is the fact that the cost is going to vary widely as well. We've estimated and performed a lot of projects, and in terms of the capital stack, there are cases where infrastructure is a very small percentage of the capital stack, but I've also seen projects where infrastructure can be 40% of all the capital required to electrify a fleet, and the balance being vehicles. So infrastructure is a very big part of the equation. It needs to be contemplated a lot earlier than it often is.
And what are some of the challenges you guys have run into in infrastructure implementation?
So there are a few challenges that I would call out. Previously, I mentioned one, which is complex stakeholder management. When we think about the customer, the utility, different folks from the municipality and authorities having jurisdiction, that requires complex stakeholder management. So that requires skills in project management and communication, but largely the challenge is how do you align all these stakeholders to move a project forward? Second challenge is site identification. Not all sites are created the same. So the cost is going to vary widely from one site to another. The infrastructure that's needed is going to vary from one site to another. And I don't think it's necessarily understood that a lot of work should be done to identify the right site for infrastructure. The last one that I would call out is many of the projects that we've worked on are in deep urban environments. That presents risk in terms of how do you not disrupt surrounding areas, businesses, in the community. The other risk that comes with that is sometimes environmental risk. There can be risks in terms of mitigation or cleanup that are required in order to establish infrastructure.
Could you talk a little bit more about the challenges in site selection? I think that is just completely overlooked in a lot of these conversations.
Yeah, absolutely. I think it's a really important topic. An example I'll give you is the utilities are responsible for delivering power. They understand the grid. There are places where significant infrastructure can be beneficial to the grid, or there are places where there are constraints. There are places where infrastructure may make sense. So that's one facet of the issue that I would call out. The other is the infrastructure that's required is going to vary from site to site. There may be infrastructure that's needed in one location, and there's enough capacity given the utility has infrastructure already in place with a substation and a transformer, and you only need the EVSE, the charging equipment. There can be other sites where there's not enough capacity at all, and you may need a new transformer from the utility. You may need other electrical upgrades. That's going to really impact the costs, and it's really going to impact the timeline.
Okay, so what particular use cases and vehicle mission profiles are you guys seeing that EVs are making sense today?
There's a few that we are watching the most right now where we think they're the best cases. So the first is regional delivery. This tends to be vehicles that are driving 125 miles or less per day. That presents the opportunity for the vehicles to charge overnight. There's a really great case for regional delivery. Another opportunity is drayage. Those vehicles are less than 50 miles per day. So great case again, where the businesses that are electrifying their fleets, those vehicles can operate during the day and charge for long periods of time overnight. Another great opportunity is buses. So when we think about transportation electrification of buses, there's a great business case, a great total cost of ownership case, and those vehicles are driving less than 200 miles per day. The last one, and I think one of the biggest opportunities, is last mile delivery. These vehicles are driving 50 to 100 miles per day. So you think about the opportunity that exists with a FedEx, a UPS, and Amazon. There are a lot of vehicles that they have in their fleets. There are a lot more people that are shopping online today. So I think that presents tremendous opportunity, that last mile delivery space.
And what all of those applications have in common is that sort of mileage sweet spot, right? Where they drive enough per day when they can really squeeze out the operating cost advantages that EVs bring, but they don't drive so far that they need these giant uneconomical batteries like a long haul Class A truck might.
Yeah, that's a big part of the equation. Related to that is, range anxiety is one of the things that can keep fleets from actually electrifying. So mileage is a component to this. It's important that I also call out vehicle availability is another part of the equation. So when we talk about regional delivery and drayage, there are a few vehicles that are available. These tend to be medium-duty trucks. More will be available soon. When we think about buses, there's a good number of vehicle manufacturers in that space. Last mile delivery, we talked about a little bit earlier. There's a few manufacturers that'll have vehicles in the marketplace soon, but they're not necessarily available today. But watching for firms like Rivian, firms like Arrival and Ford, as they start to have vehicles available in the last mile delivery space, a lot of tremendous opportunity.
Yeah, and the corollary to that is that all of those applications we talked about are urban or suburban for the most part. And some of the main benefits of EVs obviously are there's no air pollution from the tailpipe and that they're silent. And, where are those two benefits more beneficial than urban areas and city centers? So there's a lot of these sort of synergies that come about from those applications. So again, it's a win-win-win.
Very, very much so. One thing I would add on that topic is the fact that one of the drivers of electrification is going to be total cost of ownership. In fact, that's probably one of the main ones for many fleet owners and operators. There is one other thing that we should be talking about, though, and that is mandates. There are going to be cases where states are mandating that zero-emission vehicles be used. So whether it's mandates for buses to be replaced with zero-emission buses, or we think about the state of California, there's legislation proposed that will start to phase out diesel vehicles to be replaced by zero emission. But mandate is definitely one of the things we should be watching as well. That could change the prioritized use cases as well.
Oh, that's also a good point. That's a really good point. And of course, you never want to play up the regulation side in these conversations to sort of overshadow the total cost of ownership. Runs the risk of giving credence to that detractor argument that, oh, this is all a sort of government imposed environmental agenda, when really this is just good business in a lot of cases. But that being said, the regulatory wheels are really turning in California and in Europe as well. In Europe, more so than most American states, we're even seeing diesel bans in city centers that are coming about in European cities. We were speaking with the head of sustainable mobility at IKEA recently, and they deliver their products all around the world. And this person was saying, whether it's good business or not, which of course it is, we will literally not be able to drive our diesel trucks into a lot of cities and deliver it to our customers at some point. So it's pretty much from any angle that you look at it, this is going to make sense, or already does, right?
Very much so.
Okay, so we talked about delivery and urban bus fleets being some of the best current applications for EVs. So is that where your customer base lies, or can you tell us more about who your customers are and where you're doing business?
It's a good question. It's a new industry, many different stakeholders, and we think about 4 different customer types. First customer type is a vehicle OEM. So as a vehicle OEM, they're looking for partners to help establish infrastructure for their customers. There's also cases where they're responsible for providing vehicles and infrastructure. So OEMs, vehicle OEMs specifically, tend to be one customer type for us. The second customer type for us is utilities. I mentioned the fact that we work in renewable energy. There are many cases where we're building solar farms, wind farms for utilities. EV charging is very top of mind for them. So there's some utilities that are going to be customers for us as well. A third customer type is developers. So there are developers that are looking to take on the role of establishing infrastructure, from financing to site selection to building out modeling. Developers are definitely a customer of ours. And some of the customers in the developer space we have today for renewables, they're now moving into EV charging infrastructure. And the last customer type I would call out is the end user, the fleet owner themselves. In cases they're going directly to firms like Mortenson to help design and build electric vehicle charging infrastructure.
I think it would be very helpful, if possible, to sort of walk us through a customer engagement, a case study, and maybe talk to us about what you guys learned along the way and some takeaways. And you can anonymize if you need to as well.
Sure. I'll share 2 projects that are very relevant for us right now that we're working on as we speak. So there are some fleet customers that are committed to sustainability and have really aggressive goals. So 2 examples of that would be EV100. EV100 is an organization where companies are committing to electrification of their transportation and their fleets. There's another organization called Science-Based Targets, where companies are committing to reducing their footprint. They're not necessarily saying the method that they're going to use, but there's a level of commitment there. We're seeing more and more companies that are focused on sustainability, and with transportation being one of the key levers to be pulled, there are some unique projects that we're working on right now. So one example company we're engaged with right now, they have a 5-year plan to convert their 2,000 vehicle fleet to electric vehicles. So one of the challenges with that is the fact that vehicles aren't necessarily available now for their medium duty and heavy duty fleet vehicles. They do have the ability to start to electrify their light duty passenger vehicles, but they've actually been working with us to outline how can they actually electrify their fleet over 5 years. So some of the complexity involved becomes identifying what infrastructure is going to be needed at the various sites, as I mentioned before, every site is different. So the design that's required is going to be different. The capacity site is going to be different. But what's interesting is I think that they've realized the importance to engage in infrastructure discussions a lot earlier. As I mentioned before, the process can take as little as 6 months to establish infrastructure or 2 years and beyond. So learning that each of the sites can be different in terms of what it's going to take to implement has been really interesting for us and for the customer. We're also working on a pilot at our own headquarters right now. We're based in Minneapolis, as I shared before, and we're partnered with a firm by the name of the Mobility House, based in Germany, but has presence in the US as well. In that particular case, we have chargers for our employees and guests. So 6 chargers that are on site, and we actually have solar available as well. The first phase of the pilot was looking at, is there ability to reduce demand charges to operate the chargers more efficiently with smart charging software. We're through that phase now and have determined that there is potential for us to save dollars. We've also determined that there's potential for us to add additional charging units. So we're running up against capacity on the existing meter, but by leveraging smart charging software, there's potentially the ability for us to add more chargers. The other potential learning that we're going to have on this is the benefit of pairing solar with EV charging. We already have solar in place, and we're now modeling how solar can impact our costs, and on-site generation can make us more efficient. One other project that I'll reference, and this is very early on, but illustrative of what's happening in the industry today. It's a transit customer that is looking to electrify their fleet. One of the challenges they're, however, facing is the capital that's going to be required to electrify their fleet and purchase electric buses, but also for the infrastructure that's going to be needed to support. So very early discussions, but looking at how potentially Mortenson and Capital Partners could provide infrastructure as a service. And in this case, a third-party special purpose entity would own and operate the infrastructure, and the fleet would have the ability to have charging infrastructure available. They would pay some fee, X amount of cents per kilowatt in exchange for that infrastructure. So that's a model we see emerging in the marketplace where third parties are going to come in, invest, own, and operate EV charging infrastructure, but enable the fleet to electrify when they either A, have capital constraints, or B, don't want to take on the risk of establishing infrastructure. So I think we're going to see a lot more of that in the marketplace in the coming years.
I see. And that sort of leads me into the next question here that I had, which is that yes, EVs are superior in terms of total cost for a lot of these use cases, but that doesn't change the fact that they're often still more expensive upfront. So I wanted to ask, how are some of your customers addressing that upfront capital concern? So you just mentioned one way, but could you speak more on that?
So there's a couple different ways we're seeing customers address this challenge. The one I just mentioned is third-party ownership, sometimes called infrastructure as a service or energy as a service, and several firms now looking to provide that service. Another thing that we're seeing is feasibility studies. So there can be challenges when you think about the CapEx that may be required, but in terms of a holistic view, understanding the potential savings as it pertains to fuel versus the electric infrastructure. So we're seeing firms look to complete feasibility studies so they have a holistic view, which can present a different case for electrification and perhaps justify the upfront capital investment. A third thing that we're seeing in some cases is upfitting. So perhaps a new electric vehicle may cost a certain dollar figure. There are some firms that are doing upfits. Think a Ford, think a GM vehicle. There are some firms like Motive or Lightning Systems that are upfitting, and that allows you to have an electric vehicle, perhaps at a less expensive price point. But I do think that over time, the capital required for electrification is going to come down, both the technologies for the infrastructure and the vehicles themselves. I think that the total cost of ownership and capital requirements will come down over time.
Mm-hmm. So sometimes you need to get a little more creative. Sometimes you need to look a little bit closer at the cost benefit. But longer term, this will be less and less of an issue. So maybe we could just close by just having you maybe summarize or leave us with some parting thoughts about EV infrastructure.
Sure. There's a couple key points we talked about today, and one is infrastructure is the biggest barrier to electrification. I think it's more complex than sometimes believed or understood. So the sooner that fleets can engage infrastructure, the topic of infrastructure when they're thinking about electrification, I think the better. As we mentioned before, there can be complexity in implementation. Costs are going to vary widely. Timelines are going to vary widely. And in order to have a holistic view, infrastructure needs to be a part of the equation very early on.
So infrastructure first.
I think so. I think the vehicles are very exciting, very sexy. They certainly are part of the discussion early on too, but don't forget about infrastructure.
Okay, got it. That makes a lot of sense. Well, hey, Joffrey, I'd love to thank you for joining us today on the podcast and sharing some of your insight. Let's catch up again soon. Update us on all the good work you guys are doing.
Thanks, Edward. Great talking to you.
Thanks a lot. Take care.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.